The uncertain position of electrons. Origins. Far from the ancient Greek, natural philosophers tried to explore the elements that construct the world. Since the scale of atoms is too small to see, we have to observe experimental phenomena and explain it with the theories we have. If there is something that violates the theories we have, we try to redo the experiments or publish new theories in order to improve the theory system. Development. Tracing back to the 5th century BC, Democritus had already thought of the conception of atoms. If we cut things into smaller and smaller pieces, what do we get? Practically, the word atom comes from Greek. It means the smallest thing that cannot be separated. But in 1904, J.J. Thomson did a famous experiment. Through digging deeply of the cathode ray, he found a kind of negative particle that is smaller than the atom and built up a plum pudding model. Then Niels Bohr made up a Bohr model in 1913 based on Ernest Rutherford's experiment. The experiment was done to prove that the model of Thomson was correct. Unfortunately, he failed. He found that there is a part of the atom that has a small volume but has most of the atom's mass. Then he published a new model called Rutherford model. It imagines that the electrons orbit around the center of the atom, which is called nucleus. The model was criticized by the scientists at that time. It was believed that charges will radiate electromagnetic waves if they have acceleration. Thus, Bohr tried to explain the model with electron energy levels. Though the explanation isn't correct, it still gives a positive impact to the theory system. Quantum physics. The model we are using now is based on quantum physics that is conceived in the late 1900s and early 2000s. We still think that electrons are around the nucleus, but not circularly moving. Owing to the scale of electrons, they present either as particles or waves, also known as wave-particle duality. How it presents depends on the experiment we do. Based on the theorem of quantum physics, we cannot know where the electrons actually are at any time, but we can predict a space that the electrons will mostly be in, which we call it orbitals. That doesn't mean that we can't find electrons out of the orbitals. It's only said that most electrons can be found in the orbitals, and the probability of finding electrons decreases exponentially out of the orbitals. Therefore, we can probably find the electron from the other side of the observable universe. The orbitals are different from others since they have different energy levels. The ones that are close to the nucleus have less energy. Conversely, the higher. Why do we care about electrons? Chemists focus a lot on electrons. That is because most chemical reactions are highly related to the electrons. Where the electrons are sometimes decides whether the reaction happens or not. If two atoms don't get close enough or can't find the right way to insult, the chemical reaction won't happen. It is also important to know how the electrons make the bond between atoms. The ionic bond is caused by the exchanging of electrons between two atoms that have a big difference in electronegativity. The covalent bond is related to the sharing of electrons between two atoms whose electronegativities are similar.